I think band people and render people should be gone in the gym right now. Yeah. Double checking there wasn't someone else who was in here who was like, oh no, I forgot. I thought that would be a voice, but anyway. Your calendar, I did just change it up just a little bit. At one point we were going to try, E for effort, we were going to try to do 4.8. Forget it, we're stopping at 4.7. So, we're finishing 4.7 today. That 4.7 homework is going to be due tomorrow, and we're not packing in another section. Last year, sadly, did not get to 4.8 either in regular pre-cal. It is what it is. Basically, 4.8 is just further application of what we've been doing in more triangle problems. You've already seen triangle problems in the beginning of Chapter 4, so I'll go ahead and we'll skip over 4.8. Don't worry, it's not going to be on the quiz, on the quest on Wednesday. It's not going to be on the quiz, it's not going to be on the quest. Your homework sheet, I just want to make sure you guys don't have any questions. Sorry, wrong class. Your homework sheet looks a little funny. Did some of you realize that some stuff has been crossed out?
Yeah.
Okay. Because I'm trying to shorten it so that I don't overwhelm you with tons of work here when there's a lot of stuff going on in a lot of different classes. So what I did is in 4.7, I cut down the assignment. I didn't want to totally take everything out because I didn't want to just erase it all because in the future year, I really hope that regular pre-cal is doing this like it was 2 years ago, which would have been us finishing this about a week ago, and doing a full homework assignment with the full section 4.8, anyway, so we keep on going from there. I am going to go ahead and, online, I think I've already done this, I am going to uncross out, can I say that, the test review, because we are going to have or be able to do a day of review / homework questions tomorrow on 4.7 and some practice before the quest on Wednesday. I'll probably talk about the final a little bit as well tomorrow, but I'll save the quest until Wednesday. That way you guys have a day in between. Calculus has to go right into a quiz tomorrow. With no review. But you guys, I will make sure that you have that review day tomorrow for us to go over homework questions, and we can work on this little review down here. But we are skipping section 4.8. I think I need to go back in and cross out 4.8. Your calendar is now up to date. Let's go ahead and get back into notes then. Our goal is to finish 4.7 with our short baby class period today. But we can do this, kiddos. Okay? We're talking about inverse. And inverse is going backwards. You've got to know the unit circle well enough to be able to go forwards and backwards. We give you a couple moments as I take roll to go ahead and get down what you need. We started filling this out on Friday, but a few of you guys didn't quite get set up. We're going to go back and we're going to cover arc tangent. We're going to go back and cover arc tangent. So we're not going to cover arc cosecant, or arc secant, or arc cotangent in as much depth as we covered, or are covering arc sine, arc cosine, and arc tangent. Because basically, to do those other inverses, we're just going to think of the reciprocals of arc sine, arc cosine, and arc tangent. So we have one more in detail to do. And then we need to just practice unit circle backwards. So Jordan and Joseph are both Brendan / Dan. But they're both Brendan. Anyways, you guys know the little kids, it just kind of goes fast. As you guys are writing your notes, can I please give you the same? Say the same challenge. If you don't know, little kids really look up to you guys, especially the little ones, like elementary, or even the 6th graders, 7th graders. Sad thing is 8th graders. You guys remember your 8th grade year? 8th graders look up to the high schoolers and start trying to become them way too early. Can I just give you guys a plea that in a day and age when our culture is trying to obliterate any innocence left in childhood, can you please try to be a good example to them in the bleachers, in the stands, as you walk around, give them smiles, don't make fun of them. They used to be little too. Just
try as much as possible to preserve their innocence. When they're looking around the gym, and you know they do, especially the little preschool kids, they're so cute, right? When they're looking around and they see you guys, and you're goofing off and being like, oh, this is dumb, you're being stupid with your friends, you're talking the whole time, being disrespectful. Our culture's giving them enough of that. Don't give them more of a reason to lose respect for authority, to the easiest way I can say it is just to lose innocence. We live in a broken world, and that's very true, but as much as you guys can, please try to be a blessing to them today. You're not going to sit down and have conversations with them or anything like that. They're not even in their needs necessarily, but just as much as is possible, be kind to them and try to set a good example. Sound good?
Yes.
I would really appreciate it. Staff would really appreciate it. We would appreciate that every day, because if you guys don't realize that there are lots of younger kids on this campus, culture's doing enough of that already. And for any of you that had innocence taken away for whatever reason, mentally, spiritually, emotionally, physically, I'm sorry for that. I'm sorry for the ways that maybe you felt like you had to grow up too soon. But as much as possible, try to preserve others' innocence, okay? Sound good? Alright, here we go. Inverse cosine, inverse tangent. We worked a lot on inverse sine. I'm double checking real fast. I think it's just Joe and Jordan. Okay. Let me zoom in. Okay, so we're way too zoomed out right now. Let me zoom in.
Remember how many answers your calculator gives when you hit second sine or second cosine. How many answers does your calculator give, kiddos? Just one. But what did we see on Friday as far as, if you remember, how many answers are possible to come out for an inverse problem?
2, usually in each rotation of the unit circle. How many times can you rotate to get
A lot.
lot? Infinitely many. You keep rotating. They're called coterminal angles, right? Angles that end in the same place. I'm going to throw up another trig function. Let's do tangent inverse. Let's do cosine inverse first. We haven't really done tangent yet. Cosine inverse. Calculators out if you have them. Let's be in degree mode. Remember radians, we can't really see the decimals. I mean, on tests and stuff, you need to know radians, and that's because we're going to use it. Let's do cosine inverse of, let's do -1/2. Now, don't tell me the answer. Forget it in degrees. Cosine inverse of -1/2. We're looking at our cosine inverse function up here. We talked about how cosine inverse, just like sine inverse, needs to be cut down or else it will not be a function. And we need it to be a function if for no other reason, which there are others, but if for no other reason, then your calculator needs to be able to give you one answer and one alone. And so cosine inverse is cut down to only include angles between, only to include angles between 0 and pi. Now, okay. Which means cosine is only looking in quadrants 1 and 2. Now you guys should have an answer in your calculator that goes along with the degree measure. Cosine inverse of -1/2. If you were to look in your unit circle, the filled out one in your notes, section 4.2 or 3, you'd be looking for when are the x's -1/2. And in our unit circle, the x's will be -1/2 in 2 places. People know unit circle so well you know it backwards. Hopefully you'll be able to get to both 2 pi over 3 and also 4 pi over 3. In your filled out unit circle, both of those would have an x value of -1/2. Now those are not the only possible answers where the x is -1/2, because we could also turn and keep turning and get to, let's see, that'd be 6 pi over 3 plus 2, 8 pi over 3, plus 2 more, 10 pi over 3. You keep on rotating and add another 2 pi, or subtract another 2 pi. Long story short, there are infinitely many different answers, but your unit circle would show you these 2. If I'm looking for just one, question, cool kids, which one am I going to choose? The second quadrant one, because the third quadrant is not allowed. I'm only going between 0 and pi. So I'm going to choose the second quadrant one. Cosine is -1/2 at 3, 2, 1 at 60 degrees, and the second quadrant, which is 2 pi over 3, or 120 degrees. Do you guys agree?
Yes.
Good. Once again, remember, the second cosine button, just like the second sine button says, give me a ratio. Give me an answer to a trig problem. Give me wait, this is a cosine, so which sides is it? Which sides would it be? Remember, it's always a ratio of sides. Which sides would it be if this was your cosine? Come on, the Indian princess. So who's cosine?
Oh, adjacent.
Okay, so it says, give me an adjacent over hypotenuse, and I'll tell you the angle that goes with it. Remember? Inverse trig says, give me the ratio. Give me the adjacent over hypotenuse for a cosine. Give me that, and I'll go backwards to the angle. But how did we know to choose this? Well, the calculator said so. Well, how did it know how to choose it? Cosine inverse only gives us angles or answers in the first or second quadrants, as shown by the limited range. Now, tangent. You guys remember tangent? It repeats over and over again. He has some vertical asymptotes. Do you remember where his vertical asymptotes are? Careful. Pi is the cotangent. 0, pi, 2 pi, 3 pi. Where's tangent? Pi over 2. Negative pi over 2 and pi over 2. Tangent straddles the axis. So we have negative pi over 2 to pi over 2. Is tangent optimistic or pessimistic? Wait, pause. What happens halfway in between? Yeah. It doesn't have halfway in between. What's that called? That special point. Inflection. Point of inflection. That's halfway in between. At 0. And then tangent, I already heard someone say it's positive. Jackie was showing it. I think Nick was saying it's optimistic. Okay, there's my tangent. But what does tangent keep doing? So if I was to flip this guy across the y equals x line, inverse is flipped, you would actually end up with something like this. And just like with sine and cosine, if I were to take all the tangents and flip them, question, would this be a function? No. So just like with inverse sine and inverse cosine, inverse tangent says, you gotta restrict. And the nice thing about tangent is one full cycle passes the vertical line test. One full cycle of an original tangent passes the horizontal line test. Which means that we don't need to cut a cycle. We don't need to only take a piece of tangent cycles. But the funny thing about tangent is that tangent only repeats every pi anyway. So he's going to have the exact same domain restriction as sine, except negative pi over 2 and pi over 2 cannot be included in the interval because he has vertical asymptotes there. So we're going to keep it an open interval. And the weird thing is about his domain is unlike sine and cosine that are stuck between negative 1 and 1, tangent can go on forever. So the range of the original will be the domain of the inverse, which will be negative infinity to infinity. But how that looks in the unit circle when you're trying to pick out answers. Cosine can only be in quadrants 1 and 2, 0 to pi. Sine can be in quadrants 1 and 4, negative pi over 2 and pi over 2. And tangent is the exact same. Tangent inverse. We'll be looking in quadrants 1 and 4. Because you're allowed to go up 90 or down 90. You're allowed to go up pi over 2 or down pi over 2. So, let's do an example. Kiddos, in your calculator right now, since tangent is allowed to be anything, sine and cosine couldn't go beyond 1 or negative 1. So as soon as you went to sine inverse of 1.1 or 1.01, we did that on Friday. Or sine inverse of 2 or 5 or 10 or 12 or a million or negative a million, negative 30, negative 27. All of those would be DNE, 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 unless you were plugging in something between 1 and negative 1.
Since tangent is allowed to be anybody, in your calculators right now, I want you to do second tangent of any number, positive or negative. Go. Degree mode. In your calculators, plug in second tangent of any number. Any number, I don't care, positive or negative. It could be super high, super low. Only do one. Only do one.
And I'm going to ask you guys for the angles that you get. Because remember, the answers are angles. You should be in degree mode. Okay, anybody with a calculator, you should have right now on your screen second tangent, which is tangent inverse of any number. I don't care, positive or negative, plug it in. I'm going to ask you for your answer. Josh, which is your answer? Just do second tan, any number, I don't care what.
1.56.
Is the answer, right? And you're in degrees? You're okay. Okay, try it again. I mean, it could be 1 point degree, that's just kind of random.
Oh yeah, now it's 89.53.
Okay, that makes more sense. Okay, 89 degrees. Is that in between negative 90 to 90?
Yeah.
Okay. Who else has a calculator? Michael, what'd you get?
I put tan negative, what was it, the inverse of tangent to 3, and I got 71.56.
Cool, 70 something, in between negative 90 to 90. Yes.
Did the
What'd you
exact
get?
same thing, but negative, and I got negative 71.56.
Okay, negative 70 something. Hey, is that in between negative 90 to 90?
Yes.
Joel, what'd you put in?
I put in inverse tangent of 2 and I got 63.43.
63 in between negative 90 to 90?
Yeah.
Yeah, who else has a calculator? Chris, what'd you put in?
I got inverse tangent of 420 and I got 89.86.
He's getting super, super close, but it's still in between negative 90 to 90. Yeah.
Yeah.
Lady, what'd you put in?
I put inverse tangent of 5 and I got 78.68.
In between negative 90 to 90. Guess what? If we had a classroom of 500 kids and I told all of them to put in whatever stinking number they wanted, the tangent inverse, guess what all of those angles would be in between? Between 90 and
90 and 90.
90, negative 90 to 90.
Oh.
If it's positive, Joel, pause. If it's positive, Joel, pause. If it's positive, 0 to 90. If it's negative, 0 to negative 90.
Got it.
But if I just say either positive or negative, it'll be negative 90 to 90. What if I did the exact same thing with cosine inverse, but I said you're only allowed to put in numbers between negative 1 and 1? What are all those angles if I had a room full of 1,000 kids? All of them with calculators, all of them participating. And I said, put in any number between negative 1 and 1. All of those angles will be between 0 and 180. Every single one. So we have to know the restrictions to be able to choose the right answers. Let's keep going. Sorry guys, I'm trying. Okay. Let's label some stuff just like we did on Friday. What's going in? Let's let me do it right the first time. Wasn't your class the one I did it wrong the first time? Lozanda. Whatever's going in to an inverse. All those numbers that you just typed into inverse tangent, they were all representative of ratios of sides. What goes into an inverse is what comes out of a trig. What comes into an inverse is the same thing as what comes out of a normal trig, which is the same thing as a ratio of sides. And guys, if it's a cosine, what is that ratio? Representative of? Adjacent over hypotenuse. Good. The ratio of sides, specifically adjacent over hypotenuse. Whatever goes into a tangent, inverse, is what comes out of a tangent. Still going to be a ratio of sides. Goodness. But what ratio would that be for tangent?
Opposite of the adjacent.
So what you're putting in when you hit second cosine, second sine, second tangent is the ratio. So what are you getting out? You're getting out y values of the inverse, which are really domains of the original. Trig has two things. It says, give me a this and I'll give you a ratio. Or inverse trig says, give me a ratio and I'll give you a this. What's the other piece of the puzzle? What's the this? It gives you a ratio, you give it a 0 to 180, negative 90 to 90.
Agreed.
Which measures? Angles. You get out angles when you put in ratios to inverse trig. You get out ratios when you put in angles to normal trig. You get out angles when you put in ratios to inverse trig. You get out ratios when you put in angles to normal trig. Domains and ranges switch. X's and Y's switch. Angles and ratios switch when you're doing inverse. Quick reminder. You know that? Cosine inverse of x is? Oh, you don't remember? You gotta make it very memorable. No. Not what?
That was intense, I'm not gonna lie.
That is not how you do secant, right?
No.
What does this mean? Cosine? Read it.
Inverse.
Inverse. Inverse of cosine or cosine inverse. This does not mean reciprocal. True?
Right.
If you really want to do reciprocal on your calculator, look on your calculator and find the button that says x to the negative 1. I think it's on the far left-hand side.
Mhm.
That will give you the reciprocal of anything that you want. Type in 5, hit that button, it'll be 1/5. Type in 0.5, hit that button, it'll be 2. That button is the reciprocal button. Second cosine, second sine, second tangent is not the reciprocal. Those are all inverses. So I'm going to write over here, tangent. How do you read it? Tangent
Inverse.
is, what am I going to do? Not. What?
A.
No, 1 over.
Yeah, 1 over tangent of x 4.
Not true. Every test, someone makes that mistake, and I try, and I try, and I try. Not true.
No, it's gonna be me.
All right. Kiddos, first example. Tangent inverse of -1. Is it possible? Sure. You can plug anything into tangent inverse.
Yeah.
He has no restrictions.
Really?
What is he? Calculator. No, stop.
Oh.
Tangent inverse of -1. Question. In the cheater chart, my cheater chart people, is there any place where you write down tangent equals 1?
Yes.
Square root of 3 over 3, 1 square. Oh, 1.
1 square.
When did that happen?
When tangent.
Square root of 3 over 3, 1 square root of 3. It's not 30, it's not 60, it's at
45.
45.
Yeah, gotcha.
But wait. 45 is in the first quadrant.
Oh my goodness.
I need a negative
You have to
tangent.
go backwards.
I'm looking here. Or here. So I need to go.
The third quadrant.
Why? I needed a negative. Wait, not first quadrant. I needed a negative. Wait, why didn't I go to the, I don't know, second quadrant or third quadrant? Look at your restrictions. Tangent inverse. All tangent inverses will only be in between what angles? I said negative 90 and 90.
Would you look at that?
What if I was to ask you to do something like tangent inverse of negative 5,287?
Somewhere between.
Somewhere between negative 90 and 90.
Start praying first.
I can tell you this part. If you think about tangent being always optimistic, right? Can I show you tangent? Always optimistic. Look. Tangent's always optimistic. Negative 5,287. Isn't that going to be way down here?
Somewhere.
And what is on that edge of my tangent? That's positive pi over 2. What's this one?
Negative.
This is stinking close to negative 90. Who's already plugged it in? Noah, what'd you get?
Negative 89.989.
How many 9s until you see a number?
Or it's 989.
Oh, 989. Not as close as I thought. Struggle. But is there an answer? Yes. Why? Tangent inverse says give me anybody. I don't care. Sine inverse, cosine inverse says no. Only give me values in between. Oh. No.
Oh, wait, what do you mean?
Only give me numbers. Only give me ratios in between.
No.
Wait, what?
You're switching them. Careful, you're switching them. Only give me numbers in between -1 to 1.
Yeah.
I'll give you answers. Sine inverse between -90 and 90. Or cosine inverse, I'll give you answers between 0 and 90. But sine and cosine, remember. Sine and cosine says, no, I'm only allowed to take numbers in between -1 and 1. Why? Because sine and cosine only went in between -1 and 1. Tangent says, give me anybody. Why? Because he went through everybody. Okay. What if they were to give you something like an angle and some sort of ratio? Like, I don't know, let's say they give you that the opposite side is 5, hypotenuse side is, I don't know, say 11. And they want you to solve for theta. Could you solve for the third side of a right triangle? Sure. Do you have to? No, they want theta. How can I find theta? Jacob sees opposite, that was you, right? He sees opposite. He sees hypotenuse. He's like, okay, I can take opposite. I can put it over hypotenuse as long as I use what trig functions? Oh, but kiddos, how do I find theta? Algebra says if there's a sign, undo that sign. How? Division? No. Sign's not multiplication. Subtraction? No. Sign's not addition. How do I undo a sign?
Inverse of sign.
Inverse. How do I undo a square root? I square it, the inverse. How do I undo an ln? E to the, I inverse it. How do I undo a sign? I inverse it. Sign inverse says, booyah, he's gone. And when I do the one side, so theta is equal to, would you have to do that in your head because you're in circle? No. Sine is 0, 1/2, root 2 over 2, root 3 over 2, or 1. That's not any of those. So, second sign, calculator, what do we got? I'm still writing. Should be something pretty close to 30 degrees.
27.0356917.
27-ish. Nice. If you have to get rid of sine, you have to use sine inverse. Gotta get rid of cosine, gotta use cosine inverse. Gotta get rid of tangent, gotta use tangent inverse. Okay. That was one example. Here's another example. What if they give you something funny like sine of 5/3 plugged, 5 pi over 3 plugged into an arc sine? Guys, compositions, PEMDAS. Don't we always start in the inside? Alright, what's sine of 5 pi over 3? 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Got it. 60-degree angle in the fourth quadrant. Sine is the y value. You go down a lot. Maybe some of you could eventually get to negative root 3 over 2. God, no unit circle. Some of you algebraic ones might look at that and might have thought like, oh, the answer is 5 pi over 3. Dun, 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 dun. Arc sine and sine cancel out. Dun, 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 dun. You're wrong. Dun, dun. Because is this guy in between negative 90 and 90?
No.
He'll never come out of the sine inverse. But he does get me what to look at to say, okay, I can get to this place by going all the way around. But if I'm going between negative 90 and 90, what's another way of getting there? That would be between negative 90 and 90.
The reverse.
I can go that way instead. This is the legal one that would come out of your calculator. Not 5 pi over 3. That's not legal. That's not in between negative 90 and 90, negative pi over 2 to pi over 2. But going the other direction, negative 60, that's legal. Or negative pi over 2. That's legal. How about the second one? Cross them out. It's just pi. Is it? Plug it in your calculator. Cross it out. It's just pi. And that's in between 0 and pi. That's legal, right? Cross it out. It's just pi.
Great.
It's legal. It's different than A.
Less,
Who's gotten an error?
Domain.
I'm not that domain.
Error, domain
Domain.
restriction. Domain problem. Why? I don't understand. You should just be able to cross them out.
that's what it said.
Question.
That's where you go wrong.
Because they're two different.
Cosine inverse doesn't say give me anybody. Cosine inverse says I'm only allowed to take values in between -1 and 1. Pi is 3.14159 waves.
Whoa.
This, DNE. Why? Because the start on the inside. It's not possible. Cosine inverse, you have to plug in a number in between -1 to 1. Otherwise, DNE all day long. So, could there be places where you think you can just cross, go? Yes, be careful. Just because you cross to solve equations does not mean you can do it all the time, because we have these funny restrictions that lead us, I don't know, not astray, but just a little bit off.
Off the path.
Mm.
I'm sure Mount was much, but kind of.
Mm.
This is kind of an advanced idea. It's a good one, but I really need us to look here to end today. Oh. This is the last thing we need to talk about. We have not talked about inverse cosecant, inverse secant, or inverse cotangent. So how on earth are we supposed to do one? I have one down here at the bottom.
Give up.
Cosecant equals 1 over sine. Secant equals 1 over cosine. Cotangent equals 1 over tangent. So a lot of you guys would think if we needed to do cosecant inverse, wouldn't a lot of people think, oh, 1 over sine inverse, dun 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 dun. Wrong. Oh, why? Cosecant says, you know what, my ratio is the reciprocal of his ratio. My y is the reciprocal of his y. Here's the struggle. The ratios in inverse happen on the inside. So to solve, we're going to do 1 over on the inside, not the outside. To do cosecant inverse, to do secant inverse, same thing, but with cosine this time. With cotangent inverse, with tangent inverse. I know it's weird, and yet it is oh so true. And if I had tons of time, I would try to show you all the whys. But long story short, cosecant, secant, cotangent say, give me the ratios and flip them. Inverse says, wait, the ratios are on the inside. So flip on the inside. So kiddos, you're not going to probably have time to plug it in your calculator, but how would you solve arc cotangent of 5.25? Which is the same thing as cotangent inverse of 5.25. There is no cotangent inverse button. What are you going to do? Tangent inverse of
1 over 5.25.
legal way to solve. If you're a highlighting starting person, I'd highlight and star that. Kiddos, listen carefully. Listen carefully. There seems to be on the schedule a break between now and chapel, but that's only because we have a lot of people to get into the gym. Get to your lockers, put your stuff away, go straight to the gym. Got it? Going straight to the gym. Wait a second. Going to the gym. Straight to the gym. Don't get everybody in trouble.
Yeah, I know.
Go a little faster. Remember, these, and these.
All of them.
I've seen some clips that was just like, nope, not playing this game anymore. Game, you know, like, yeah.